How would you feel if you have built over 100 circuits and half of them failed? Let me show you how to troubleshoot a failing design. We have covered this design in previous videos. The idea, the concept, and the actual design, and then building the circuit. So go back and watch those videos if you haven't yet. But then, what I didn't tell you in previous videos is that when we have built these, we had all kind of problems. When over half of these circuits did not work, and here's the design right there, and we could not tell why. And this made us really nervous because we're trying to get these out before the holidays to our friends and partners, and we're racing time basically. The symptom was on a lot of these trees, the LEDs would not come on. The processor, so the micro right here, that would work fine. It connects to the PC, we can load software on it, everything works as expected, but then the LEDs would not come on. Check the voltage on the LEDs, voltage is there. Check the signal, grab a scope. Scope the signals, these are smart LEDs, so they're controlled over digital wires, over SPI bus or SPI-like bus. So what I did then is grab my trusty benchtop power supply. Instead of using USB, connect the power supply to the tree, and then try different voltages. And sure enough, when we go like 5 volts or more, the lights will not work anymore. Go below that, it's like different numbers, and then they would start working beautifully. And this is what I noticed. Let me write it down because we're going to need this later. So at 4.7 volts, everything worked beautifully. Anything above that, we had problem. Now looking at the data sheet of the LED, just to make sure that we are within voltage, the LEDs work up to 5.3 volts. So 5.3 volt is okay for the LEDs, but then we're giving them 5 volts and they would not work. Why is that? And there seemed to be a magic happening at 4.7 volts. I went back to the data sheet and started checking to see what voltage levels are expected by the LED. So you would have, like, let's say this is the micro right here. Okay, and that would be like right here. And then the micro is connected. There are 2 pins that go to the LED. So let's say this is the LED. And there are 2 signals over here. The clock and the data go into the LED. Now, typically, most electronics chips you would use today work fine with 3.3 voltage levels. But I wanted to verify that because the LED, remember, the LED is running off 5 volts. And the micro is running off 3.3 volts. So we have 2 different voltage levels, but everything should work at 3.3 volts, even though if it's running at 5. Most cases. Checking the data sheet has no mention whatsoever of what the expected voltage levels. Then I'm like, well, hold on a second. Let me go back to the usual, the circuits that are not compatible with every voltage, and those would typically show source times 0.7. And if we do that, if we do 5 volts times 0.7, this will give us 3.5 volts. If these chips, if these LEDs expect voltage level to be, for a high level to be at 3.5 volts, of course it's not going to work. The chip is 3.3 volts. Where would the 3.5 come from? So the LED would never see the pin going high. The pin is going high up to 3.3 volts but the LED would not see it going high because it expects it to be at 3.5 volts. So that could be it. But why 4.7? Why 4.7 work? Now let's work this backwards. So 3.3 volts over 0.7 equals 4.7 volts. Haha, this is one of those moments where you're like, I don't know what's going on. How come half are not working? Figure out the problem. Go see production. Go see the data sheet. Maybe they did not solder the parts correctly. But then when you do the math and you go through the process and you see the results, this makes complete sense. That's why it's working fine at 4.7 volts. Now I still have over 100 trees that I need to ship in like 2 days, and I cannot just redo them. We cannot trash them. So we need to find a way to fix these trees. So what I did is go back to the design software and check the traces inside, and then I sure enough found a trace that is between USB, that's going like, because USB is the 5-volt source, between USB going into the tree. And that's on the surface. This is a 4-layer circuit, so if it was on the inner layer, it would be very hard to get to. It was right on the top. So, and then I got an X-Acto knife, severed the trace, so we cut that trace, and now there's no voltage going to the LEDs anymore. So we lost the connection between the 5-volt input and the LEDs. And then looking down here, you see that little wire. So down here on this little wire, there were 2 vias. One was the 3.3 volts, and one was going to the LEDs. So this is after where we cut that trace. If we connect these, if we add a little wire between the two, it will bring the 3.3 volts out to the LEDs. So now the LEDs will be powered off 3.3 volts. And when the LED is powered off 3.3 volts, the concern we had before was not an issue anymore, because the high level needs to be 0.7 times 3.3. We are within range. Everything would work as expected. Added the wire, tested a couple of them. Everything worked great. And then we had to go back and manually, on hundreds of boards, cut the trace, add a little wire. But at least we managed to get these out to our friends and partners. And some received before Christmas, some received after Christmas. But hey, it's a fantastic tree. Where do you get one of these? Until next week, take care.